Hello everyone, how are you doing? So today we are going to discuss calculus here on Minds of AA. So calculus, firstly, it's not calculus, it's infinitesimal calculus. Actually, it's infinitesimal calculus, but infinitesimal calculus doesn't roll on the tongue, so we call it calculus simply. So calculus is a Latin word which means small pebbles. We at ancient times we used to do maths with pebbles, so it's like that simple. It's mathematics by definition. It's mathematics of change. You can apply calculus to everything what change. So guys, there are a lot of things in the universe that change continuously. The change is happening everywhere, whether it's entropy, all other things. So we just so guys, what we learn about calculus, or what I have learned about calculus in my school or college, that you will learn rules, memorize the rules, apply them to thousands of situations, and that's it. We know calculus. But you will learn rules. You will definitely learn rules. But if learning rules is what calculus is, then you don't know what calculus is. The creation and the working of calculus is such a genius process that it blows everyone's mind. Newton and Leibniz were two guys who gave this concept of calculus to the world simultaneously but separately, but both the guys from different locations gave published the same concept of calculus. So guys, let's start. The point starts with Newton, that he was sitting under the tree. The apple fell down and he thought, why it's falling down, why not upside? So the biggest blow in that time was gravity, what we call as gravity. It's very big concept. So Newton thought of gravity. The gravity came into play. Then Newton thought, way up there is moon. What's holding it? It must be gravity, gravitational force of Earth, what we call as gravity. So, but why don't it collide with Earth? So Newton started calculating the expression for the gravitational force. What he found was that the gravitational force is inversely proportional with the distance of two bodies. That r is the distance between the two bodies. So Newton thought of doing something like this. Let's plot this on a graph. For example, this is a graph. This is that this is for example, this is this is r, and this is gravitational force F. So it is something like, so guys, if this is force, gravitational force F, and this is the distance between the two bodies r. So what he did is he started calculating the change in the gravitational force with respect to the distance r. But with this curve, it was something like impossible, impractical that time in mathematics, that we can't calculate. What we do simply, when we have to calculate a change, for example, we have a straight line. So we take 2 points anywhere on the line, compare them, and this m, the slope or gradient of this line, gives us a rise. We do rise over run. Then this formula gives us the gradient or the slope of that line. But doing this stuff with this is not working out. So what Newton did, because this curve is continuously changing, you can't, when you compare these 2 points, you will get a different answer, and you compare other 2 points, you will get a different answer. So what Newton did was he thought of something, drawing a tangent to the curve, anywhere to the curve, and finding the gradient or slope of that tangent. But the another problem came into existence, was that when we calculate the gradient of a curve, we take 2 points and compare them, the rise or the run of that curve. But what's happening here is you don't have 2 points. By definition, tangent have only 1 point which touch the curve. So it was another very tricky problem in which Newton faced in developing the calculus. So see what he did. So Newton thought of visualizing this problem of tangent on a circle. What he did was, what he said was that if we draw the same tangent to a circle, it's not perfectly a circle, just assume it's a circle. He said that if we draw this tangent to the circle, let's draw some parallel lines to this tangent. Let's do that. Change the color. Let's do. Oh, once again, sorry guys. These are not also the parallel lines. So let's just assume these are parallel lines. So this is what mathematics is all about. Sorry for that. He said on these secants, these guys are called secants. So hope you know about this. So he said that if I have these secants on the circle, so I have 2 points to compare on every secant. So I just, in this sequence, when I approach to this tangent, I just do it. I'm coming closer, closer and closer to the value of the gradient of that tangent. Because I have 2 points of a secant, I can calculate the gradient of the secant. So if I'm approaching the tangent, so I must be closer to the gradient of the tangent. So the problem was solved here. But here, these both guys, Leibniz and Newton, introduced a new language called what we call as, just write it here, limits. Limits was the biggest breakthrough in the calculus. After the introduction of limits into the mathematics, what Newton and Leibniz did was this. For example, we take a function y is equal to f of x. This is making a curve something like this. Now we draw a line over here. This line will act as a secant to the curve. So we have 2 points, so we can find the gradient of the secant. So we will just compare these 2 points. So we will find, sorry guys for the zoom out, we will compare these 2 points with another coordinate axis. We will find the gradient. So let this be x, and this distance between these 2 points be h. So this becomes x plus h, sorry, and this becomes, if this is x, this will become f of x, and if this is x plus h, this will become f of x plus h. So guys, here we are. So if we want to calculate m, the gradient, or what we call as slope, it will be equal to f of rise over run. This is the rise on the y-axis, so it will be equal to f of x plus h minus f of x somewhere over here, and or run will be equal to h, because the distance, the change in x in on the x coordinate is in the x coordinates is h simply. So here we got the gradient or slope of the secant, but this is not what we want. What I want is gradient of the tangent. So what I need is h equals to 0 simply. But if I put here in this equation h equals to 0, so the equation is exploding, it's not working out. So here the language was used, that is the limit h, sorry, this h approach to 0. Here this thing is called the gradient of that tangent we needed. So this thing here has a very great significance in calculus. It's the fundamental stone of differential calculus. We call it first So guys, we call it first principles of calculus. So that's it. We are with the gradient of the tangent. But another important thing is that this is not just a simple gradient. This is not just, when we put the limit, this is not just a gradient. This will give, when you put the different values, it will give a different value of the gradient. So it's not just a gradient, it's a, we call it gradient function. So guys, it's a gradient function. So remember, this is the fundamental stone for, this is the basic fundamental of differential calculus. So remember this, don't memorize it. We have the whole process. What we have learned is to just memorize it. I shown you how it came into existence. So this is the first principles of calculus. That's it for today. Thank you for making me a part of your day. See you soon in the next video. Thank you. Bye bye.